Hi there. During this session I'm going to be talking about the impacts and the effects of global warming. So let's start off by thinking about how global warming has been covered in the news. And here's some data from actually quite a while back, but some of the stories which were picked up from the BBC came out as the 10 warmest years on record have occurred since 1983, and 7 of the hottest years have occurred since 1990. So we're saying that the tail end of the 20th century there was above normal temperatures. Extreme weather conditions have been taking place. Extreme heats, extreme floods, extreme droughts have taken place across the world. Mountain glaciers are melting. So studies by the British Antarctic Survey has identified that even the Antarctic Peninsula itself had warmed by 2.5 degrees centigrade and is causing the ice sheets to disintegrate. This in turn had an impact on the decline of the penguin populations. Even more stories. Oceans are getting warmer, expanding, so therefore low-lying nations like the Maldives and Seychelles and the Samoas are going to be disappearing, and this could also have an impact on weather structures such as the El Nino effect. So therefore this is going to exacerbate global warming. Plants, birds and animals are migrating further northwards because of the warming airs and the sea temperatures, so displacing other plants and animals. And malaria is becoming more and more widespread in further northern latitudes because the mosquitoes are able to survive in places where they previously couldn't because of the increased temperatures. Global warming and the impacts are immense, and they do have, or will in some way probably touch and impact each and every one of us. Let's think about this in a little bit more detail. Okay, so first of all, some facts. Rising sea levels. Here's some data on this graph looking at the average increase in sea levels at the Battery Tide Gauge in New York. New York is particularly susceptible to the rising of sea levels. Sea level rising at approximately 1.8 millimeter per year for the past century, but since 1993 to 2000 this rate increased to 3.1 millimeters per year. So there's clearly been an increase in rate of rising sea levels. This is caused by, well, crucially it's caused by the melting of the polar ice caps. This is exacerbated by the thermal expansion of the oceans and also the retraction of glaciers means that there's less and less water held in these glaciers, so more water is flowing into the oceans, so causing an overall increased level. Impact to the rising sea levels. So these sea levels, as they rise, there's going to be displacement of aquatic life, the flooding of coastal regions, destruction of island nations, and also with that the displacement of populations. So these are going to be the impacts of rising sea levels. Now we can do some calculations to do with this. There's something known as the coefficient of the volume of expansion. So the change in volume is equal to the coefficient of volume of expansion multiplied by the original volume multiplied by the change in temperature. Now this coefficient of volume expansion is given to the material we're talking about. So water has a value of 2 times 10 to the minus 4 per Kelvin. Air has a value of 3,400 times 10 to the minus 6 per Kelvin. So this is the change in volume, or the how much of a change in volume there is depending on the change in temperature. Now with this information we can actually start to answer some fairly basic questions. The area of the oceans of the Earth is about 3 times 10 to the 8 kilometers squared with an average depth of 3.7 kilometers. Estimate the rise in the sea level after a temperature rise of 2 Kelvin and then comment on this answer. So I'm going to give you a moment to use that formula to try and work out the expected rise in sea level. Now you've done that, let me take you through the maths. Total volume of water is going to be the area times the depth. So that gives me 3.6 times 10 to the 8 times 3.7, which gives me 1.3 times 10 to the 8 kilometers cubed, or as it happens, 1.33 times 10 to the 18 meters cubed. That's the overall volume. So the increase in volume is what I'm interested in. If I know the original volume, the coefficient for expansion due to water, and the change in temperature, and I know these values, 2 times 10 to the minus 4, 1.33 times 10 to the 18, and times 2, the change in temperature is by 2 Kelvin, means that the change in volume is going to be 5.3 times 10 to the 14 meters cubed. That doesn't answer my question though. The original question was the change in depth. So I continue with this, and the change in height is going to be the change in volume divided by the change in area. So 5.3 times 10 to the 14 divided by 3.6 times 10 to the 14 gives me an increase in sea level of 1.5 meters. 1.5 meters seems a fairly dramatic amount. So let's think about and analyze this question a little bit. First of all, the assumption does assume uniform heating of water, of all water, and does not consider an initial water temperature. As the higher water temperature takes place, there's actually going to be more evaporation and more cooling taking place. So this may counteract this change. And another big feature is, as the sea level rises, it needs to cover dry land, so therefore increasing the area and decreasing the height overall, so therefore that height is not going to be quite as high as this calculation leads us to believe. So that gets us a chance to think about the impacts of global warming on planet Earth.